No left-hand. Well, okay, so this is the problem we're working on. Manufacturer wants to know that their items knows that their items' lifespan are normally distributed according to a normal with a mean of 2.1 and a standard deviation of 0.7. And we want to know what proportion of items are going to have a lifespan greater than 2 years. So let's look at not only how do we get the answer here, but how do we show our work. Okay, so we know that the items' lifespans are normally distributed with a mean lifespan of 2.1 years and a standard deviation of 0.7 years. So to begin, let's see if we can get that in there. Come on. So to begin, oh, there we go, 0.7 years. So to begin, we want to draw a picture of that normal curve. We start by drawing our horizontal axis and just sketching in the general shape of the normal curve. And it's always important to have this written somewhere in the picture too, because that tells the reader quickly, oh, okay, here's my mean, here's my standard deviation. And now in our picture, the mean always goes right at the center. So we know this right here is 2.1 years. And the standard deviation we've been given is 0.7. So if I go to the inflection point in my curve, the part where it goes from kind of going most steeply down, right there, I know that this is going to be 2.1 plus, 2.1 plus 0.7, which is 2.8. And if I want to fill in one below, then I'm going to say this. Oh, come on, it doesn't want to do dotted lines with a straight line. This is going to be 2.1 minus 0.7, which gives us 1.4. I'm in trouble writing there, which gives us 1.4. Let's say, yeah, 1.4. All right, and now for the question at hand, they want to know what proportion of items are going to last greater than 2 years. So for greater than 2 years, we figure where's the number 2 going to be? It's going to be somewhere between this 1.4 and this 2.1. So we could say maybe it's going to be around here. This is 2 years. We want to know the proportion of items that are lasting more than 2 years. So if we think about area here, let's change to blue to shade. We want all the area to the right of the number 2. I'm talking about areas. That's always telling us the proportion of items. So to answer our question, we want to know what is this area. How can we calculate that? Well, the calculator command that we can always use to calculate areas is going to be the norm CDF command. So when you're writing out your work, you want to show that's the command you're using. When we enter values into norm CDF, we always think about, first of all, what is the area we're looking at? What is the left-hand boundary of that area? So here it's the number 2. So 2 I would enter first. What is the right-hand boundary of that area? Well, in this case, that area goes forever to the right. So we say that's infinity. But the way we put that on the calculator is a 1E9. So we go 1E9. And then we have to tell it the mean and the standard deviation of our distribution. So it would be 2.1. And then the standard deviation 0.7. And if we type this in our calculator, let me go ahead and do that. So I'm going to do second vars to get that normal CDF command. And then I'm going to enter that 2, 1E9, 2.1, 0.7. And the answer I get there is 0.55. That shouldn't be there. It's a 0.556. If I round to 4 decimal places, 68. So that tells me that this area that I've shaded in blue is about 55% of the total area under the curve. So you want to indicate that that area is 0.5568, where the total area is 1. And this would be my final answer for that question.